everybody. Welcome to our first lesson of Unit 10, which is all about quadratic functions. Today, we're going to learn what a quadratic function is. We're going to learn some important vocabulary about quadratic functions, how to identify different parts of quadratic functions, and that is going to give us the foundation for the rest of this unit. So let's get started. A quadratic function is any function written in the form f of x equals ax squared plus bx plus c. So previously in this year, we have learned about linear functions, which make a straight line and are written in the form f of x equals mx plus b. We have learned about exponential functions, which form a curve. Currently, we're in the time of COVID, so we're talking a lot about exponential functions in the news. Exponential functions are written in the form f of x equals a times b to the x. Today we're going to talk about quadratic functions. Quadratic functions form the shape of a parabola, and we'll get to that vocabulary word in a moment. A quick review of what this function notation means. F of x is how we say this, not f times x. The x is whatever we are inputting, and f of x represents our output. So the x tells us what we're going to substitute in for x, and f of x is our output. Let's talk a little bit now about the shape of a quadratic function. A quadratic function is shaped like a parabola. A parabola is a U shape. So quadratic functions can be concave up, which means they open upwards, or they can be concave down, meaning that they open downwards. Each of these U shapes are called parabolas. So let's look at a quadratic function and actually break down what some of the parts are. So this is the first quadratic function we are going to look at. The first thing we're going to look at is the y-intercept of this quadratic function. The quadratic function is this darker U-shaped line right here. And the y-intercept is where that line crosses the y-axis. In this case, it's this blue dot that is our y-intercept. Remember, the y-intercept is wherever on the graph x equals 0 or where the line crosses the y-axis. The next thing we're going to look at are these two pink dots. These are our x-intercepts. This is where our parabola crosses the x-axis. In quadratics, sometimes the parabola will cross the x-axis once, sometimes twice, sometimes not at all. Here is an example of it crossing the x-axis twice. These are our x-intercepts. And when we talk about quadratics, we're actually going to need a couple other vocabulary words for x-intercepts, because sometimes our problems are going to use different words to describe those x-intercepts. Sometimes they'll use the word zeros, sometimes roots, sometimes solutions. If you ever see a zero, a root, or a solution in a problem, it's talking about the x-intercepts of those quadratics. So we have our y-intercept, we have our x-intercepts. X-intercepts are also called zeros, roots, and solutions. The next thing that we are going to look at is this purple dot at the very bottom of our parabola. That point is called the vertex. The vertex is the highest or lowest point on a parabola. The vertex is going to be where the maximum or the minimum point on the parabola is. In this case, our parabola faces upwards, so we have a minimum point. But if our parabola faced downwards, was concave down, we would have a point on the top, and that vertex would be a maximum. The final part of a quadratic that we need to be able to identify is this green line right here. This line is called the axis of symmetry. If you notice, it goes straight through this parabola, making it so that both sides of the parabola are even. That is what we mean by symmetry. It's a line that divides the parabola perfectly in half. It's always going to be a vertical line, and it's always going to go through the vertex because it's always dividing our parabola in half. The axis of symmetry, we are going to write equations for. So the equation of the axis of symmetry is always going to be x equals and then a number. And that number is where the line crosses. In this example, our equation for the axis of symmetry would be x equals 1 because our axis of symmetry crosses the x-axis at 1. We'll look at an example in a second for how we make the equations for axes of symmetry. So those are all the key pieces of a parabola. We need to know where the y-intercept is, where the zeros, roots, solutions, or x-intercepts are, where the vertex is, and whether that vertex is a maximum or a minimum, and what the equation is for the axis of symmetry. Let's look at an example. So here's the example we're going to look at. I apologize, I had to white out because I did the wrong equation at first. We're going to start with the y-intercept. So the y-intercept is where our parabola crosses the x-axis. So our y-intercept is going to be right here. In this case, that point is at 0, -3. Then we're going to find our x-intercepts, also known as our zeros, our solutions, or our roots. The x-intercepts are -3 and -1. So the point -3, 0, and the point -1, 0. Then we need to find our vertex. Remember, the vertex is the highest or lowest point on the graph. In this case, the vertex is at the top, and it's at the point -2, 1. Sometimes we'll be asked to find the maximum or the minimum. When we're asked to find the maximum or the minimum and not the vertex, we only need to list the y-coordinate. So the maximum of this graph, the highest the graph goes on the y-axis, is 1. The minimum of this graph means I go as low as I can go. Oh wait, there are arrows. It's going to keep going for forever and ever and ever. It's going to keep getting lower. There is no minimum to this graph. Now, if the graph was concave up, so it was shaped up like this, then the minimum would be right at the bottom and there would be no maximum. For a quadratic graph, we cannot have a maximum and a minimum. We can only have one or the other, depending on whether our graph is flipped up or flipped down. Finally, we are going to look at our axis of symmetry. So our axis of symmetry is going to be the line that we can use to cut this graph in half. So let's draw a line right there. It turns out that our axis of symmetry goes right through x equals -2. So our axis of symmetry is x equals -2. There's a lot of new vocabulary in this lesson. We learned the word parabola, we learned the word vertex, maximum, minimum, axis of symmetry, quadratic formula, and we're going to get a bunch of practice in with all of this. But for right now, we need to be able to identify all the parts of a quadratic graph. Thanks for listening. I hope this was helpful.